Okay, uh, so we continue our lecture to find out the probability of SY operators with when the eigenvalue is minus h cut by 2. Okay, so we know when lambda equals to minus h cut by 2, then the corresponding eigenvector is equals to is denoted by sy minus k. It's equals to 1 over root 2 1 minus I, 1 over root 2 minus I. Okay, so using this eigenkate we can find out the probability for getting minus h cut by 2. Okay, so now the measurement of probability of probability to get minus h cut by 2 is equal to brass sy minus brass psi mod square. Okay, a mod square. This is the corresponding mathematical expressions. So it is equals to basically we know the sy minus brass is equals to complex conjugate of the given kit. It is equals to basically 1 plus I. Okay, 1 plus I. This is the complex conjugate, and now introduced in this expressions. So now it is equals to 1 upon root 2 1 plus I, and now introduce the psi. It is nothing but 1 upon root 5 1 plus I root 3, 1 plus I root 3. Okay, so now this is the mod square and this is the mod square. Now we calculate this expression and we finally get our what is the probability to get minus h cut by 2. Okay, so now these two terms minus 1 by root 2 and 1 by root 5 it's multiplied with each other, and we get 1 upon root 10 whole square, and now 1 plus I and 1 plus I root 3, 1 plus I root 3 mod square. So okay, it is equals to basically 1 upon 10, and now multiply these two matrix is equals to basically 1 plus I plus root 3 I. Okay, this is mod square, and it is equals to basically 1 upon 10 mod 1 plus root 3 1 plus root 3 I mod square. So now we calculate the mod of this complex term. Okay, now we calculate the mod of this complex term. It is equals to basically 1 upon 10 mod of root under 1 square plus 1 root 3 square mod square. Okay, so now this value is nothing but equals to basically this is equals to 1 upon 10 mod root under 1 plus 1 plus 2 root 3 plus 3. Okay, plus 3 mod square. It is equals to 1 upon 10 root under 5 plus 2 root 3 mod square. So it is equals to basically 5 plus 2 root 3 upon 10. 5 plus 2 root 3 upon 10, it is equals to half plus root 3 upon 5. So the probability of getting plus h cut by 2. So now the probability of getting plus h cut by 2 is nothing but 1 upon 2 minus root 3 upon 5. Probability of getting minus h cut by 2 is nothing but half plus root 3 upon 5. Root 3 upon 5. So basically option C is the correct answer. Option C is the correct answer. Please take a note. Option C is the correct answer. Please take a note. Now we get another problem. Now we get another problem, that is question number 13. Okay. Now we get another problem, that is question number 13. In question number 13, basically what they asked in question number 13, it's very important. Question number 13. ठीक है. Question number 13. Question number 13. Consider a particle of mass m in a harmonic oscillator potential of the form V of r equals to half of m omega square plus 4x square plus 9y square plus 4z square. The maximum number of electrons that can be accumulated in the energy level E equals to 21 by 2 h cut by omega, h cut by 2 h cut omega. Okay, so there is given potential of one in a harmonic oscillator, 3-dimensional harmonic oscillator. Question number 13 is question number 13. Question number 13. In this question, consider a particle of mass m in a harmonic oscillator potential of the form V of r. V of r is nothing but half of m omega square, half of m omega square, 4x square plus 9y square plus 4z square. Okay, now the maximum number of electrons that can be accommodated in this energy level. They ask, with respect to this potential, you can find out the maximum number of electrons that can be accommodated in the energy level, and that energy level have a energy h cut 21 by 2 h cut omega. Okay, so basically यहाँ पे एक energy given है, and that is 21 by 2 h cut omega. In this energy level, what are the maximum number of what are the maximum number of electrons that can be accumulated in this energy level? Okay. So first of all, we can find out the energy expression with respect to this potential. First of all, we can find out the energy expressions of 3-dimensional harmonic oscillator with respect to this potential, and then we can find out the energy, and we can compare with this energy, and then can find out what is the maximum number of electrons can be accumulated in this energy level. Okay, so this is very important question, right? This is very important question. So now we can simplify this potential. First of all, we can simplify this potential. V of r, it is equals to half of m omega square 4x square plus half of m omega square 9y square plus half of m omega square 4z square. Okay, now we can simplify this expression is as like it, half of m 2 omega whole square x square plus half of m 3 omega whole square y square plus half of m 2 omega whole square z square. So it is equals to basically half of m omega 1 square x square plus half of m omega 2 square y square, half of m omega 3 square z square, where omega 1 is equals to 2 omega 2 equals to 3 omega, and omega 3 equals to again 2 omega. Okay, so using this expression, using this expression, we can find out the value of energy of a three-dimensional harmonic oscillator is the energy of this expressions, energy of the three-dimensional harmonic oscillator. Now, energy of the given oscillator energy of the given oscillator is Enx Ny Nz equals to Nx plus half h cut omega 1 plus Ny plus half h cut omega 2 plus Nz plus half h cut omega 3. So this is the energy expression of the harmonic oscillator. This is the energy expression of this harmonic oscillator. Enx, Eny, Enz equals to Nx plus half h cut omega 1, Ny plus half h cut omega 2, Nz plus half h cut omega 3. Okay. So now introduce the value of omega 1, omega 2 and omega 3, and now the given energy expression is E Nx Ny Nz is nothing but Nx plus half 2 h cut omega plus 2 h cut omega plus Ny plus half 3 h cut omega plus Nz plus half 2 h cut omega. Okay, 2 h cut omega. Please note down 2 h cut omega. Now multiply with 2. The first term is equals to 2 nx plus 1 h cut omega plus 3 ny plus 3 by 2 h cut omega plus 2 nz plus 1 h cut omega. Now take h cut by omega for 3 terms. Now take h cut by omega from 3 terms, and we get the expressions of this energy. We get expressions of the energy is equals to basically 2nx plus 1, 3ny plus 3 by 2 plus 2nz plus 1 h cut by h cut omega. So now again simplify this expression. And we get basically 2nx plus 3ny plus 2nz plus 7 by 2 h cut omega. Okay, so from this from the given potential we get the energy expressions 2nx plus 3ny plus 2nz 7 by 2 h cut omega. This is the energy expression corresponding to this potential. This is the energy expressions corresponding to this potential. Okay, corresponding to this potential we have the energy expressions. Now this energy expression is compared with this energy value, and we can find out the maximum number of electrons can be accumulated within this energy level. Okay, please take a note. Okay, that's fine. So now we can compare the energy expression with the given energy value. Now compare this energy expression with the given energy of the value. Basically, this energy is given in the questions, and this energy is nothing but h cut 21 by 2 h cut omega. So okay, given energy is compared with this energy levels. So now this energy given energy is basically okay. Given energy is equals to h 21 by 2 h cut omega, and this energy is equal to this energy value. Okay, so now 2nx plus 3ny plus 2nz plus 7 by 2 h cut omega equals to 21 by 2 h cut omega. Now h cut omega and h cut omega cancel each other. Okay, cancel each other. So it is equals to basically 2nx plus 3ny plus 2nz plus 7 by 2 equals to 21 by 2. Now simplify this expression. Simplify this expression. It is equals to 2nx plus 3ny plus 2nz equals to 21 by 2 minus 7 by 2. It is equals to 2nx plus 3ny plus 2nz equals to 2. It's basically 14. So it is equals to 7. So now the given expression is nothing but 2nx plus 3ny plus 2nz equals to 7. This is the one type of equations, and using these equations we can find out the value of total maximum number of electrons can be accumulated in the given state. Okay, so now take a possible value to find out the maximum number of electrons of the given state. We now choose the state nx, ny, nz. What are the possible combinations? Next we trying to find out what are the possible combinations of nx, ny, nz. Okay, and within this possible combinations we get a corresponding state, and using this state we can easily find out what are the maximum number of electrons can be accumulated within this energy level or energy state. So now we can find out the possible state for this level. Now we can find out the possible state. Okay, now we can find out the possible state. Possible state. Okay, now we can find out the possible state, and this is equals to 2nx plus 3ny plus a possible state. So now it is put nx equals to 0, ny equals to 1. We take nx, ny and nz, substitute the value, and we get the value is equals to 7. Nx equals to first of all 0, ny 1, n2 is 2. So its value is basically 7. So this is the one state. This is the possible state 0, 1, 2. This is the possible state 0, 1, 2. Next 2, 1, 0. Next put 2, 1, 0. So another state is basically 2, 1, 0. This is another state, and also another is basically 1, 1, 1. Nx equals to 1, ny equals to 1, and nz equals to 1, and also we get 7. So the corresponding state is equals to n 1, 1, 1. Okay, so we get basically 3 state. Okay, 3 state. As we know, according to Hund's principle, each state only acquire 3 energy levels, acquire 2 electrons. Each state consists only 2 electrons. So we get 3 states. So total number of or maximum number of electrons can be accumulated within this energy level is equals to 3 cos 2. It's equals to 6. Okay. So as you know, each of this state can be accommodates only 2 electrons, as each state can be accommodate only two electrons, hence maximum number of electrons can be accommodate each 3 cross 2, it's equals to 6. Each state accommodates only 2 electrons. That's why we get only 3 states. So each state accommodate 2 electrons. Given 3 states, we get maximum number of electrons is 6. Okay. So for the given problems, in this way or in this manner, we can find out the maximum number of electrons in each energy level. Okay. So first of all, आपके पास एक पोटेंशियल गिवन होगा, उस पोटेंशियल से आपको एनर्जी एक्सप्रेशंस डिफाइन करना है और उस एनर्जी एक्सप्रेशंस को जो गिवन एनर्जी लेवल होगा उसके साथ आप कंपेयर कीजिए. देन यू फाइंड रिलेशनशिप्स nx ny nz के रेस्पेक्ट में आपके पास एक रिलेशन मिलने वाला है. उसमें आप nx ny की वैल्यू सब्स्टिट्यूट कीजिए and then find out the level and then count out the number of level, and we know each level consists only 2 electrons. So that's why then you can find out the what is the maximum number of electrons can be accumulated of the corresponding energy level or energy state. This is the procedure, you can follow it and you get the answer. Okay, so basically option D is correct for the given problem. Option D is correct. Okay, option D is correct, please note it. नेक्स्ट हम लोग क्वेश्चन नंबर 14 लेने वाले हैं. दैट इज वेरी इंपॉर्टेंट क्वेश्चन. डब्ल्यू के भी अप्रोक्सीमेशन से क्वेश्चंस पूछा है बेसिकली, है ना. तो इस क्वेश्चंस को हम लोग देखने वाले हैं. दिस इज द डब्ल्यू के भी अप्रोक्सीमेशन प्रॉब्लम. ओके, डब्ल्यू के भी अप्रोक्सीमेशन. सो दिस प्रॉब्लम इज बेस्ड ऑन डब्ल्यू के भी अप्रोक्सीमेशन. लेट्स टेक क्वेश्चन नंबर 14. Questions number 14. Okay, question number 14. First of all, we read the questions and can finalize the parameters and then find out the corresponding formula and we can proceed our solution method. Okay, we can proceed our solution method. So the energy values of En, of a particle in a potential of the form V of x equals to lambda mod x to the power 6 h found from the WKB methods are proportional to. So आपके पास एक पोटेंशियल गिवन है और उस पोटेंशियल को यूज करके आपको बेसिकली एनर्जी एक्सप्रेशंस फाइंड करना है ना, एनर्जी वैल्यू फाइंड करना हो ना फॉर WKB मेथड, यूजिंग द WKB मेथड. ओके, using the WKB method. So the given potential is V of x equals to lambda x to the power 6. So the given potential is nothing but V of x equals to lambda x to the power 6. We can find out the formula of energy expression. Okay, using this potential expression, you can find out what is the value of energy level with of nth level energy of the nth state. Okay, energy of the nth state. So as you know the basic formula, as v of x is nothing but lambda x to the power r, lambda x to the power r, then state energy is equals to is proportional to basically n to the power 2r upon r by 2 and lambda to the power 2 upon r by 2, 2 upon r plus 2. Okay, so from this expression r is basically 6, from this expression r is basically 6 and substituted in this equation, so it is proportional to n 2 into 6 upon 6 plus 2 lambda 2 into 2 upon 6 plus 2, it's proportional to n to the power 12 upon 8 lambda to the power 12 upon 8, it's proportional to n 3 by 2 and lambda to the power 1 by 4. So now using the WKB methods, you can find out the energy expressions for the corresponding energy state of the given potential from the given potential. So now the energy expressions become En is directly proportional to n to the power 3 by 2 and lambda to the power 1 by 4. This is your corresponding expression or result. So basically options A is the correct answer. Option A is correct answer. This is very easy question. Option A is the correct answer. Okay, option K is correct answer. So please take a note. Next we come to question number 15. Next we come question number 15. Question number 15. This is very famous problem. Question number 15 is very famous problem. Question number 15 is a very famous problems. They ask the Hamiltonian of a three-level system is represented by the matrix. Okay, the Hamiltonian, question number 15, the Hamiltonian of a three-level system is represented by the matrix. एक मैट्रिक्स गिवन है that is nothing but 8 का ओमेगा 1 0 0 0 2 0 0 0 2. ठीक है, matrix Hamiltonian matrix of a three-level system. Also an Hermitian operator, also given an Hermitian operator in matrix forms, that is lambda 0 1 0 1 0 0 2. This is the operator, Hermitian operator given in matrix forms. If the system starts out in a state, if the system starts out in a state psi x of t, psi x t equals to 0, in this state is given c1 c2 c3, also mod c1 square mod c2 square plus mod c3 square is equals to 1. See that a value of lambda, the probability that value of lambda will be obtained while measuring a cap on the state at time t each. बेसिकली आपको प्रोबेबिलिटी फाइंड करना है, ठीक है, प्रोबेबिलिटी फाइंड करना है when we get the value is lambda, लैम्डा के रिस्पेक्ट में आपको इस ए कैप जो ऑपरेटर है, इस ए कैप ऑपरेटर का मेजरमेंट करना है, ठीक है, इसका आइगन वैल्यू लैम्डा मिलेगा, उस लैम्डा आइगन वैल्यू के रिस्पेक्ट में जो आइगन केट मिलने वाला है, उस आइगन केट के रिस्पेक्ट में आपको प्रोबेबिलिटी फाइंड करना है, ठीक है, ठीक है, ऑन द स्टेट ऑन टाइम टी. सो बेसिकली हियर द स्टेट इज गिवन इज टी इक्वल्स टू 0 स्टेट, बट आपको प्रोबेबिलिटी फाइंड करना है इसी स्टेट के रिस्पेक्ट में, बट दे आर नॉट t equals to 0 for t equals to something t. Okay, so this expression can be written in terms of time t. So we can write this expression is a time dependent wave function, and then we can find out the probability for measurement the eigenvalue lambda of this operator a cap. तो जो ऑपरेटर है, इस ऑपरेटर का आइगन वैल्यू लैम्डा मिलने का प्रोबेबिलिटी फाइंड करना होगा फॉर दिस स्टेट. ठीक है, फॉर दिस स्टेट विथ रिस्पेक्ट टू दिस स्टेट. दिस इज द वेरी इंपॉर्टेंट कॉन्सेप्ट. वी टेक आइगन वैल्यू. फर्स्ट ऑफ ऑल फाइंड आउट द जो हैमिल्टोनियन है, इस हैमिल्टोनियन का हम लोग आइगन वैल्यू फाइंड करने वाले हैं. ठीक है, इससे हैमिल्टोनियन का आइगन वैल्यू हम लोग फाइंड करने वाले हैं, और उस आइगन वैल्यू के रिस्पेक्ट में वी कैन फाइंड आउट द कॉरेस्पॉन्डिंग आइगन स्टेट. ओके, एंड देन वी कैन आइगन स्टेट ऑफ ए कैप. फर्स्ट ऑफ ऑल वी कैन फाइंड आउट द आइगन स्टेट ऑफ हैमिल्टोनियन ऑपरेटर, then we can find out the eigenstate of this a cap operator, and then we can find out the probability of measurement. So basically from Hamiltonian, the given Hamiltonian, okay, these are given data, all are the given data. In this given data you can find out the corresponding problem. So first of all take a Hamiltonian and find out the eigenvalue. So this Hamiltonian is nothing but h cut omega 1 0 0 0 0 2. Okay, now the eigenvalue of this expression is e1 equals to h cut omega, e2 equals to 2h cut omega, e3 equals to 2h cut omega. Okay, so now the corresponding expression eigenvector is 1 ket is equals to 0 0 1. This is k2 equals to 0 1 0. This is state 3 is equals to 0 0 1. Because why? These all are the diagonal matrix. This is a diagonal matrix. So for diagonal matrix we get always eigenkate 1 0 0. For another eigenvalue we get another eigenkate 0 1 0, or for another eigenvalue we get eigenkate 0 0 1. This is very easy. So for this Hamiltonian we get the eigenkate 1 0 0, 0 1 0 and 0 0 1 eigenkate, and we can denote it. First eigenkate is k1, second eigenkate is to k2, and third eigenkate is k3. This is my own representations. Okay, this is my own representation. Please remember. Now we can find out the eigenstate of a cap with eigenvalue lambda. Okay, ये जो a cap operators है ना, ये a cap operators है, इस a cap operator का हम लोग eigenstate calculate करने वाले with respect to eigenvalue lambda. This is very important. Then we can find out the probability. Okay, so इस a cap operator का जब eigenvalue आपको 1 lambda मिलने वाला है, उसके respect में आपको eigenstate find करना है. Okay, eigenstate find करना है. So now let us consider A, B, C be the eigenstate, corresponding to the eigenvalue lambda of operator a cap. Okay, operator a cap. So let us consider this is the eigenstate a, b, c, or you can choose x1 x2 x3. This is your own way. How can you represent it? Okay, so let us consider ABC, that's the eigenstate of the corresponding eigenvector eigenvalue lambda of the operator a cap. So it is equals to lambda. So now the corresponding matrix equation is lambda 0 1 0 1 0 0 002 into ABC equals to lambda A, lambda B, lambda C. This is the corresponding matrix equations. So it is equals to basically now multiply it with this two matrix and compare with this two value. So it is equals to 0 lambda 0 lambda 0 0 0 0 lambda 2 lambda not lambda 2 lambda A B C equals to lambda A lambda B lambda C. Okay, lambda A lambda B lambda C. Now again multiply these two matrix, and this is equals to basically first terms is lambda B, okay, as 0 multiply these expressions 0 lambda B, it is equals to lambda B and then lambda A 2 lambda C equals to lambda A lambda B lambda C. Okay, so it is equals to basically lambda B equals to lambda A equals to lambda B, or 2 lambda C equals to lambda C. So from these two equations we can get A equals to B. Okay, from these two expressions we can get A equals to B. So basically the corresponding eigenvector. So now the eigenvector for the eigenvalue lambda of operators A cap each A, B, C is nothing but 1, 1 and 0. So we can normalize this, and this is equals to 1 upon root 2, 1, 1, 0. So this is the eigenstate for the given eigenvalue lambda of this operator. So for the eigenvalue lambda, we can find out the eigenstate, and this will be 1 upon root 2, 1, 1, 0. Okay, let's now express these expressions with respect to time. This is time independent state. Now this time independent state is expressed in terms of time dependent state, because in questions they ask find out the probability that the value of lambda will be obtained while measuring a cap on the state time t. Okay, ये जो स्टेट है टाइम t इक्वल टू 0 के लिए है, बट आपको स्टेट को t इक्वल टू t के लिए फाइंड करना है, देन यू कैन फाइंड आउट द प्रोबेबिलिटी विथ रिस्पेक्ट टू द स्टेट, है ना? ओके, okay, now express this state. Now express this state. This state is psi x t equals to t. So it is equals to basic c1 e to the power minus e1 I e1 to I e1 t by h cut, है ना, minus I e1 t upon h cut, c2 e to the power minus I e2 t upon h cut, c3 e to the power minus I e3 t upon h cut. This is the corresponding expression. You can find out any stationary state converted to time dependent state by exponential e to the power I e to the power et by h cut. You can convert these expressions. So basically this is equals to E1 minus E1 is nothing but h cut omega, right? H cut omega I, not h cut omega, 2h cut omega, 2h cut omega T upon h cut C2 e to the power minus I 3h cut omega, not 3h cut omega, it is h cut omega, sorry, थोड़ा सा इसको अच्छे से लिख लेते हैं C1 E1 का वैल्यू h cut by omega, so e to the power minus I h cut omega t upon h cut C2 e to the power minus 2h cut omega 2h cut omega on h cut C3 e to the power minus I 2h cut omega upon h cut. So t, it's t. H cut it cancel each other. So the corresponding state is nothing but C1 corresponding state is nothing but equals to C1 e to the power I omega t, C2 e to the power 2I omega t, C3 e to the power 2I omega t. This is the state. Now we can find out this probability of getting eigenvalue lambda for the corresponding state from the corresponding state. So we can scalar product and mod square. So now therefore the probability of finding the lambda, please take a note. Okay. This is the important expressions. We can erase all the case. We can erase all the case. This is very important and this term is very important. Okay, so we can find out the this is omega t, I omega t, okay, I omega t. So we can find out the probability of finding lambda. Now probability of finding lambda. Now probability of finding lambda. Okay, so it is equals to basically equals to 1 by 2 root 2 1 1 0 multiplied with this state C1 e to the power minus I omega t, C2 e to the power minus 2I omega t, C3 e to the power minus 2I omega t and mod. Okay, so this is equals to 1 by 2 mod 1 comma 1 comma 0 C1 e to the power I omega t, C2 e to the power 2I omega t, C3 e to the power 2I omega t mod square. Okay, fine. Now multiply this 1 by 2 mod C1 e to the power I omega t plus C2 e to the power 2I omega t mod square. 2I omega t mod square, and this will be mod square is means as you know psi mod square means psi star psi, you know, psi mod square means psi star psi, so it can be also expressed of psi star C1 e to the power plus I omega t plus C2 e to the power plus 2I omega t multiplied with C1 e to the power I omega t plus C2 minus 2i omega t. Okay, so it is equals to half, this is equals to c1 mod square plus c1 c2 e to the power minus I omega t plus c2 c1 e to the power plus I omega t plus c2 mod square. Okay, plus c2 mod square, c2 mod square. So option it's basically option C is the correct, right? Option C is the correct answer. It is equals to half mod c1 square mod c2 square plus c1 c2 e to the power I omega t plus c2 c1 e to the power plus I omega t. This is your answer of probability of getting the value of lambda. Okay, in this way you can find out the various problems. Please practice all the problems. प्रैक्टिस नेसेसरी है, प्रैक्टिस करना बहुत नेसेसरी है. आपको हर एक बार क्वेश्चंस को प्रैक्टिस करना होगा, प्रैक्टिस करना बहुत जरूरी है. बार बार रिपीटेडली प्रैक्टिस करिए, हर एक प्रॉब्लम को प्रैक्टिस करिए. जो क्वेश्चन सेट आपको मिल रहा है इस क्वेश्चन सेट को एक बार खुद से ट्राई कीजिए. मेरे सॉल्यूशंस आप लोगों ने देखा, कॉपी में नोट किया, देन गो थ्रू किया, देन यू कैन ट्राई इट. क्योंकि हर बार क्वेश्चन में आपको न्यू क्वेश्चन फ्रेम होने वाला है, तो आपको न्यू क्वेश्चंस करने का आदत डालना पड़ेगा, है ना. तो आदत डालिए अच्छे क्वेश्चंस करने का, तो आपका रिजल्ट ही अच्छा आएगा. डोंट वरी. हम लोग नेक्स्ट क्वेश्चन नंबर 16 को लेते हैं. इसको नोट करिए अच्छे से. ओके, क्वेश्चन नंबर 16. क्वेश्चन नंबर 16, क्वेश्चन नंबर 16 को रीड करिए आप लोग खुद से. आपके पास क्वेश्चन पेपर है, क्वेश्चन पेपर को रीड करिए. दैट्स इंपॉर्टेंट. रीड करना बहुत इंपॉर्टेंट है, समझना इंपॉर्टेंट है. क्वेश्चन को अप्रोच सही ढंग से करने के लिए जो जो पैरामीटर इंपॉर्टेंट है उसको अगर स्ट्रॉन्ग कीजिए. स्ट्रॉन्ग करना इंपॉर्टेंट है. क्वेश्चन रीड करना आना चाहिए, उसमें क्या पैरामीटर गिवन है वो आना चाहिए, साथ ही साथ आपको क्वेश्चन में क्या पूछा है वो समझना बहुत जरूरी है. उस समय देखिए आपके पास हैमिल्टोनियन था, एक ऑपरेटर था और एक स्टेट था, है ना. अब उस ऑपरेटर का आइगन वैल्यू फाइंड करना है, उस आइगन वैल्यू का कॉरेस्पॉन्डिंग आइगन गेट फाइंड करना है, देन फाइंड आउट द मेजरमेंट ऑफ प्रोबेबिलिटी. दिस इज द अप्रोच. इस अप्रोच को समझना होगा. ओके, नाउ क्वेश्चन नंबर 16. क्वेश्चन नंबर 16, a micro particle of mass m moving on a ring of radius a lies in the xy plane and the wave functions of the particle is given by psi a cos cube phi. ओके, एक माइक्रो पार्टिकल m है, मास m है, मूविंग इन ऑफ ए रेडियस a, लाइज इन द xy प्लेन में लाइज है, एंड द वेव फंक्शन ऑफ द पार्टिकल इज गिवन बाय psi इक्वल्स टू a cos cube phi, phi being an azimuthal angle and a is a constant. If a measurement of the jet component of orbital angular momentum, if a measurement of the jet component LZ of the angular momentum the particle is carried out, the probability of getting the result is plus h cut. ओके, अगेन आपको जो स्टेट है इस स्टेट के रिस्पेक्ट में LZ का जो प्रोबेबिलिटी प्लस h कट मिलने का प्रोबेबिलिटी फाइंड करना है. ठीक है, LZ का आइगन वैल्यू प्लस h कट मिलने का प्रोबेबिलिटी फाइंड करना है. इसका मतलब स्टेट आपके पास गिवन है, वो LZ का आइगन वेक्टर फाइंड करना होगा विथ रिस्पेक्ट टू आइगन वैल्यू प्लस h कट. दिस इज इंपॉर्टेंट. देन इक्वल स्केलर प्रोडक्ट एंड मॉड स्क्वायर. दिस इज द मेथड, है ना. दिस इज द मेथड. चलिए, तो फर्स्ट ऑफ ऑल जो स्टेट यहाँ पे गिवन था, उस स्टेट को हम लोगों को अच्छे से डील करना आना चाहिए, है ना। तो गिवन psi इक्वल्स टू क्वेश्चन नंबर 16, psi is nothing but a cos cube phi. Psi is nothing but a cos cube phi. Phi is azimuthal angle. ओके, phi is azimuthal angle. तो हम लोग इसको 4 से मल्टीप्लाई कीजिए, 4 से डिवाइड कीजिए, a by 4 cos cube phi. As you know, the cos 3 theta, cos 3 phi equals to क्या होता है बेसिकली, बताइए, थोड़ा सा लिखिए अच्छे से। फोर कॉस क्यूब थीटा माइनस 3 cos phi. ओके, फोर cos cube theta minus 3 cos phi. So 4 cos cube phi equals to cos 3 phi plus cos 3 phi. Let's introduce in this expression a by 4 equals to cos 3 phi plus 3 cos phi. Okay, so when you know the cos 3 phi, it's represented as a I 3 phi plus e to the power minus I 3 phi, e to the power minus I 3 phi upon 2 plus 3 cos phi e to the power I phi e to the power minus I phi upon 2. Okay, we can express in terms of e to the power I m phi. m LZ का आपको एक्सप्रेशन वैल्यू फाइंड करना है, m का वैल्यू फाइंड करना है ना, तो देन यू कैन इजीली फाइंड आउट दिस एक्सप्रेशन. तो इससे आपको बेसिकली एक स्फेरिकल हार्मोनिक वेव फंक्शन मिलने वाला है ना. और उस स्फेरिकल हार्मोनिक वेव फंक्शन आपको अगर मिल गया, आपको m का वैल्यू पता लग गया, l का वैल्यू पता लग गया, so you can easily find out the corresponding probability. So now this is equals to basically 2 is out of this bracket, so it is equals to a by 8. Okay, e to the power I 3 pi, e to the power I 3 pi plus e to the power minus I 3 pi plus 3 e to the power I 5 plus 3 e to the power minus I 5. Okay, now multiply it with this expression 1 by root 2 pi and divided by 1 by root 2 pi. A into root over 2 pi upon 8 into 1 upon root 2 pi. This is important. 2 pi e to the power I 3 pi plus 1 by 2 pi e to the power I 3 pi, 3 by root 2 pi e to the power I 5 plus 3 by root 2 pi e to the power minus I 5. So these are the expressions. Okay, so this is express phi 3, this is phi minus 3, this is phi 1, this is phi minus 1. Okay, so root over 2 pi upon 8 into a into phi, not phi, just phi 3. This is state, another state. This is state 3 state. Okay, this state not 3 state. We can express is a phi m equals to 3 state. Okay, phi m equals to 3 state plus phi m equals to minus 3 state, m equals to minus 3 state plus 3 phi equals to m1 state plus 3 phi equals to m minus 1 state. Okay, this is the corresponding expressions of the state for the given value. Now we can find out the value of this constant value of a. Okay, now we can find out the value of a. ये जो a का वैल्यू है इसको हमको फाइंड करना है. So we can use the normalized conditions. So we can use the normalization conditions. Apply normalization conditions. Okay, apply normalization conditions. Apply normalization conditions. So it is nothing but 2 pi upon 64 mod a square 1 square. Okay, 1 plus 1 plus 9 plus 9 equals to 1. Okay, so 2 pi upon 64 mod a square 19 20 21. So mod a square equals to 64 upon 20 upon 2 pi. So it is equals to basically 16 upon 10 pi. 16 upon 10 pi. So mod a equals to root under 16 upon 10 pi. So it is equals to 4 upon root under 10 pi. 4 upon root under 10 pi. So now the corresponding state is become root over 2 pi upon 8 equals to 4 upon 10 pi into 5 m equals to 3 ket 5 m equals to minus 3 ket plus 3 phi m equals to 1 ket plus 3 phi equals to m equals to minus 1 ket. Okay, so pi cancel out, 4 cancel out. So it's basically जो स्टेट आपको मिल रहा है, हम थोड़ा सा ऊपर पार्ट को इरेज करते हैं हम लोग. ठीक है, जो ऊपर वाला पार्ट है इसको इरेज कर लेते हैं. मेरे हिसाब से आप लोगों ने कॉपी किया. ठीक है, इतना तक सही है, इतना तक आप लोग लिखिए, इतना तक लिखिए. So now it is equals to pi cancel out. So it is equals to basically 1 upon 20 root 20 1 upon root 20 ket psi m equals to 3 plus phi m equals to minus 3 plus 3 phi equals to m 1 ket plus 3 phi equals to m minus 1 ket. Okay, so it is equals to nothing but 2 root 5 phi m equals to 3 ket plus phi m equals to minus 3 ket plus 3 phi m equals to 1 ket plus 3 phi equals to m minus 1 ket. This is the corresponding state. Now we can find out the probability of getting plus h cut. It means m equals to 1. आपके पास क्वेश्चन में क्या पूछा है देखिए, प्रोबेबिलिटी ऑफ गेटिंग प्लस एच कट, मेजरमेंट ऑफ एलजेड. ओके, मेजरमेंट ऑफ एलजेड और एक्सप्रेशन प्लस एच कट के लिए पूछा है. तो एलजेड का आइगन वैल्यू बेसिकली क्या होता है, प्लस माइनस एच कट. प्लस एलजेड का आइगन वैल्यू बेसिकली होता है एम एच कट, और एम का वैल्यू अगर 1 है देन वी गेट द प्लस एच कट. प्लस एच कट है ना, प्लस एच कट. सो आपको probability of getting plus h cut find करना है. The probability of getting plus h cut, that means m equals to 1. So आपको जो स्टेट मिलेगा, इस जो स्टेट के रिस्पेक्ट में आपको प्रोबेबिलिटी फाइंड करना है phi m1. It is equals to basically phi m1 equals to this state 2 root 5 phi m3 ket plus phi m minus 3 ket plus 3 phi m equals to 1 ket plus 3 phi equals to m minus 1 ket. ठीक है, These are all orthogonal state, so its scalar product is 0. So this is our orthonormal. This state and this state are orthonormals, so it's equals to 0 1. So now the it's a mod square, it's a mod of course square, है ना? So we get only mod of phi m equals to 1, 3 is out of the kit, phi m equals to 1, 3 by 2 root 5, 2 root 2 5, phi equals to 1 mod square. This value is 1, so basically 3 by 2 root 5 whole square equals to 9 by 4 into 5, 9 by 20. 9 by 20. Its answer is basically 9 by 20. So option is B. Option is B. So please take very good question. देखिए इस एक प्रॉब्लम को हम लोग किस तरह एक फॉर्म में डेवलप किया. This is very important question. This is also another important question. Note करिए. Okay. Next take last questions of this test. Question number 17. This is very easy questions. I think this is very easy questions. इससे अच्छा इजी क्वेश्चन नहीं होगा. क्वेश्चन नंबर 17 में जो क्वेश्चन था इससे अच्छा और इजी क्वेश्चन नहीं होगा. अच्छा और इजी क्वेश्चन. देखिए क्वेश्चन नंबर 17 को हम लोग अच्छे से पढ़ते हैं. क्वेश्चन नंबर 17 है ना. क्वेश्चन नंबर 17. क्वेश्चन नंबर 17. देखिए क्वेश्चन नंबर 17. द ग्राउंड स्टेट एनर्जी ऑब्टेन बाय यूजिंग द ट्रायल वेव फंक्शन psi of x equals to x e to the power minus bx square. A is a normalized constant and b is the variational parameter for 1D harmonic oscillator of frequency omega is equals to. चलिए पढ़िए, रीड करिए अच्छे से क्वेश्चन रीड करिए. रीड करना इंपॉर्टेंट है. आपको क्वेश्चंस रीड करना पड़ेगा. क्वेश्चंस को अच्छे से रीड करिए, देन फाइनलाइज द योर आंसर. देखिए क्या पे द ग्राउंड स्टेट एनर्जी ऑब्टेन बाय यूजिंग द ट्रायल वेव फंक्शन. यहाँ पे एक ट्रायल वेव फंक्शन गिवन है. ट्रायल वेव फंक्शन गिवन था. आपके पास एक ट्रायल वेव फंक्शन गिवन था दैट इज इक्वल्स टू psi ऑफ x इक्वल्स टू ax e to the power minus bx square. Okay, this is the trial wave function. It's given in the questions, and a is a normalized constant and b is the variational parameter. यहाँ पे a क्या है? normalized constant है. normalized constant है. b क्या है? variational parameter है. variational parameters. Okay, variational parameters. आपको फॉर 1D हार्मोनिक ऑसिलेटर के लिए आपको एनर्जी फाइंड करना है, ग्राउंड स्टेट एनर्जी. सो फर्स्ट ऑफ ऑल फॉर 1D हार्मोनिक ऑसिलेटर का जो फर्स्ट एक्साइटेड स्टेट का एनर्जी एक्सप्रेशन होता है ना, वी नो फॉर 1D हार्मोनिक ऑसिलेटर 1D हार्मोनिक ऑसिलेटर वी नो फॉर 1D हार्मोनिक ऑसिलेटर ग्राउंड स्टेट का वेव फंक्शन बेसिकली क्या होता है? m ओमेगा अपॉन pi h cut whole to the power 1 by 4 e to the power m omega square x square upon 2 h cut. This is ground state wave functions. This is ground state wave functions. This is ground state wave functions. Next, first excited state wave functions is nothing but some constant x e to the power minus m omega square x square upon 2 h cut. This is the first excited state wave functions. First excited state wave functions. Okay, this is the first excited state wave functions. So this trial wave function and first excited state wave function, please note this trial wave function and first excited state wave function are very similar. So this trial wave function is basically the first excited state wave function. Okay, this trial wave function is basically looks like a first excited state wave function. So basically आपको जो एनर्जी फाइंड करना है इस ट्रायल वेव फंक्शंस के रिस्पेक्ट में, आपको फर्स्ट एक्साइटेड स्टेट के लिए वेव फंक्शंस फाइंड करना है, हार्मोनिक ऑसिलेटर. सो एज द ट्रायल वेव फंक्शंस is equivalent to the first excited state wave functions, first excited state wave function of 1D harmonic oscillator, 1D harmonic oscillator. Hence energy corresponding to the trial wave functions is equals to energy of first excited state. Energy of first excited state. Energy of first excited state, and it is equals to 1 plus half h cut omega, that is 3 by 2 h cut omega. So basically option C is correct. इस क्वेश्चन के लिए आपको ऑप्शन सी इज करेक्ट. सो नोट करिए अच्छे से. As the trial wave function is equal to the first excited state wave function of the 1D harmonic oscillator, this trial wave function is equivalent to the first excited state wave function of our 1D harmonic oscillator, and the energy of the corresponding to the trial wave function is equals to the energy of the first excited state. So for first excited state n equals to 1, so that's why you put these expressions and we get the value of this energy 3 by 2 h cut by omega. So in this way we can complete our test. First जो चैप्टर इच टेस्ट क्वांटम मैकेनिक्स का हुआ था, उस क्वांटम मैकेनिक्स का टेस्ट हम लोगों ने कंप्लीट किया 2 लेक्चर में. आप लोग इसको अच्छे से नोट करिए और रिवीजन करिए. ठीक है, चलिए नेक्स्ट क्लास में हम लोग का फिर से मुलाकात होगा और एक अच्छा टॉपिक लेके हम लोग फिर से डिस्कस करेंगे. दैट इज हम लोग इलेक्ट्रोडायनेमिक्स का क्लास बेसिकली कंटिन्यू करने वाले हैं. ठीक है, इलेक्ट्रोडायनेमिक्स का क्लास आपको कंटिन्यू करने वाले हैं. सो इलेक्ट्रोडायनेमिक्स का क्लास हम लोग डिस्कस करने वाले हैं. ओके, सो ओके, थैंक यू फॉर योर अटेंशन.